My name is Jebin. In this video lecture, I am going to explain the problem on steam nozzle. Question: dry saturated steam at 10 bar is expanded isentropically in a nozzle to 0.1 bar. Using steam tables only, find the dryness fraction of the steam at exit. Also, find the velocity of steam leaving the nozzle when number 1, initial velocity is negligible. Number 2, initial velocity of steam is 135 meter per second. So they have given two conditions. So at number 1, in case 1, initial velocity you need to take it as negligible, and condition number 2, initial velocity of the steam is 135 meter per second. Okay. So they have given the pressure of steam as 10 bar. So given data, P1 is equal to 10 bar. Then P2 is equal to 0.1 bar. So to find dryness fraction at the exit, so you need to find the value for x2 and velocity of steam of the nozzle. Okay, so you need to find the value for v2. So you need to use the steam table to find the value. So at first, so from steam table, corresponding value of pressure is equal to 10 bar. You need to write the value for SG1, then for the corresponding value of pressure is equal to 0.1 bar, you need to find write the value for SF2 and SFG2. Then you can find the value for X2. So solution. for dry saturated steam, S1 equal to SG1, which is equal to 6.583 kilojoule per kilogram Kelvin. Then from steam table, pressure FP1 FP2 is equal to 0.1 bar. We need to write the value for SF2, which is equal to 0.649. Okay, 649. Then SFG2 G2S 7.502 kilojoule per kilogram Kelvin. Okay. Then you need to find the value for X2. So therefore the dryness fraction is, so the formula for dryness fraction is S1 is equal to S2, which is equal to SF2 plus X2 into SFG2. So the value for S1 is equal to S2. The value is 6.583 is equal to, the value for SF2 is, from steam table you have find the value 649 plus X2 into SFG2 value is 7.502. So we need to find the value for dryness fraction. X2 is equal to 0.791. Okay. Then second thing is you need to find the velocity. Velocity of steam leaving. Leaving the nozzle, you need to find the value for V2. The condition one is you need to neglect the value of V1. You need to neglect the value of V1. So here from steam table, P1 is equal to 10 bar. As it is a dry saturated steam, the value for H1 is equal to the value of Hg1, which is equal to, can find the value as 2776.2 kilojoule per kilogram. Okay, then from steam table, P2 is equal to 0.1 bar. So you can find the value for HF2 is equal to 191.8. Then HGFG2 value as 2392.9. Okay, kilojoule per kilogram. Then you have to find the value for H2. H2 is equal to HF2 plus X2 into HFG2, which is equal to, so the value for HF2 is 191.8 plus the value for X2 is 0.791 into HFG2 value is 2392.9. So therefore the H2 value is 208.4.6 kilojoule per kilogram. Okay, so you have to find the value for velocity. So therefore V2 is equal to velocity V2 is equal to 44, formula is 44.72 root of H1 minus H2, which is equal to 44.72 root of H1 value is 2776.2 minus 2084.6. Therefore V2 is equal to 1176 meter per second. Okay. So if you neglect the initial velocity, you can find the value for V2. The value for V2, steam leaving the velocity at a velocity 117276 at nozzle exit. Then, so the condition number 2 is the initial velocity. You need to take the initial velocity as 135 meter per second. So the formula for V2 is equal to V1 square plus 2000 H1 minus H2. Okay, so which is equal to 135 the whole square plus 2000 into 2776.2 minus 2084.6 root of. Okay, therefore the V2 value is 1184 meter per second. If you consider the initial velocity of steam as 135 meter per second, you will get the velocity of steam leaving the nozzle as 1184 meter per second. Thank you.